Hi students, in this lecture I am going to discuss problems. Let us see first one. A barometer kept in an elevator reads 76 centimeter when it is at rest. If the elevator goes up with increasing speed, the reading will be. Let us see how to start. So keeping this in an elevator means lift. Condition is given, speed is increasing. It is going up, speed is increasing. So first focus what is barometer. So it is one instrument used to measure pressure of atmosphere. Let us see how to calculate pressure of atmosphere using that. So we are taking one glass tube. Its length is 1 meter. So taking a glass tube, length 1 meter. This is now completely filled with mercury. Now filling this completely with a mercury. This is now mercury completely with mercury. Now we are taking here one mercury bowl. This is one bowl which contains mercury. Now we are placing this by inverting this into this one. That means it will be now like this. So it is now inverted into the mercury bowl. So this is now consists of mercury completely. So this consists of mercury. So once you are inverting this tube into the mercury bowl, some of the mercury will come out into the mercury bowl. It is now mercury is up to some height. It is not completely filled. It is now after inverting. It is only up to some height. Only up to some height. For example, that height is equal to h. This height equal to h. See how it gives us pressure of atmosphere. This is now mercury. Right. So above this level, above the surface, mercury is now at it is height is h above this level. See how to get the value of h. You can see that pressure now at this point, it is equal to pressure of atmosphere. At this point, pressure of atmosphere. If I'm taking now at this point, if you're taking now at same level and same depth, I'm taking now same level and same depth, just inside the surface. I'm taking at this point, just inside, pressure equal to pressure of atmosphere. I'm taking at same level, a point here. At this point also, pressure must be equal to that of atmosphere. And remember here, this is a completely filled. So when we are inverting this into the mercury bowl, this will be having no air. This is now vacuum. There is no air in that. It is vacuum. Okay. That means in this region, pressure equal to 0. Now see how to get this height. So when you're having mercury above the surface up to some height, there must be a force which is balancing the weight of the raised liquid. Weight of this raised mercury must be balanced by some force. And we are saying that at this point there is no pressure. That means from the top there is no force acting. So now we have to focus. Its weight must be balanced by force by this part of the mercury. It must be upwards by this part of the mercury. On this part of mercury, force must be upwards. And that force is able to balance weight of this part of mercury. See how to calculate. If this pressure is now P naught, pressure of atmosphere, at this point also pressure equal to P naught, then force equal to P naught into A. This force is acting at the bottom. This is now supporting weight of this part of mercury. This force is supporting weight of this mercury, right? That is equal to weight means mg, m means area into height, that is volume, into density of mercury, that is mass into g. Okay. Now see what we get. A gets cancelled. P naught is equal to H rho G. Okay. So like this, by knowing the height of mercury column, we get pressure of atmosphere. So generally, H value will be 76 centimeters. So whenever we are saying pressure of atmosphere, we are saying in terms of height of mercury column. So 76 centimeters of mercury column. Okay. It means its value, we have to substitute here 76 into 10 power minus 2. Okay. Rho value, density of mercury 13.6 kg per metric cube, density of mercury, into G value, it is 9.8. So making the calculation, then we are going to get approximately 10 power 5 Newton per meter square. Okay. So most of the cases we are saying pressure of atmosphere in terms of height of mercury column. It is 76 centimeters of mercury column. That means we have to make this a calculation to get that value. Right? Okay. Now coming to our problem. It is given that, say the question once. Say it is given that it is kept in an elevator. Elevator means lift. Reads 76 centimeters when it is at rest. If elevator goes up with increasing speed, if elevator goes up with increasing speed, its meaning is for the lift, acceleration is upwards. Acceleration is upwards. Then the reading will be. So what happens to reading? Okay. So coming to here, pressure inside lift is independent of motion of the lift. Whether lift is having acceleration or not, irrespective of that, inside the lift, pressure will be same. That won't change. It is equal to pressure of atmosphere. That means it is H rho G. Okay. Now see what happens when it is a constant. P naught is equal to H rho G. In this we can see density of mercury. It is a constant. But coming to in the place of G, whenever lift is having acceleration, we are writing in the place of G, H rho in the place of G, G plus or minus C. Okay. Because if you observe carefully from lift to frame, if you solve the question from lift to frame, we have to take pseudo force. That means Along with mg, we have take ma, which is downwards. So it becomes now mg plus ma. Okay. So here we are taking plus a. If acceleration is upwards, minus a. If acceleration is downwards. Okay. Now focus carefully. In this problem, acceleration is given upwards because it is given that moving up with increasing speed. Okay. Then P naught is a constant. So since P naught a constant, H into rho into G plus R minus A is a constant. I am writing here. P naught is a constant. That implies H into G plus R minus A is a constant because rho is a constant. Okay. This is a constant. In first case, lift was at rest. Okay. In the place of H, it is given 76 centimeter. Rest means it is only G. So H into G. Now it is having acceleration, it is upwards. So it is now H into G plus A. So I have taken H1 G1 is equal to H2 G2. Okay, in that form. So from this we can say clearly this is G. This is G plus A. That means H must be less than 76. Right? So P naught constant. Therefore, H into G plus R minus A is a constant. First case 76 into G. That is equal to now H value into G plus A. That means from this what we can say? This value is more, then H value must be less. So less than 76. For example, in the same problem, if it is given like it is moving up with decreasing speed, moving up with decreasing speed, it means acceleration is down. Okay. So in that case, we have to take G minus C. Then H will be greater than 76. So should be very careful in which direction velocity is there and in which direction acceleration is there. Okay. So basing on that, we can decide very easily. Okay. So I hope you got clarity. Let us see next one. To construct a barometer, a tube of length 1 meter is filled completely with mercury and is inverted in a mercury cup. This is what we have discussed, right? The barometer reading on a particular day is 76 centimeter. Suppose 1 meter tube is filled with mercury up to 76 centimeter and then closed by a cord. So here what he is doing, instead of filling completely, filling only up to 76 and then closed by a cord. It is then inverted in a mercury cup. It is mercury cup, and the cork is removed. The height of mercury column in that tube over the surface in the cup will be. See where change comes. See, when we are filling the glass tube completely, and then if you invert, what happens is there will be no air in the top of the mercury. That means mercury is now up to this height. This will be vacuum, means no pressure. This is what this is the case when we are filling the tube completely and then inverting. But now here it is filled only up to 76. This is filled only up to 76. Okay, that means remaining will be air, right? If you invert this, if you invert this tube in the mercury cup, what happens is this air comes to the top. Okay, so filling up to 76, then inverting into the mercury cup. Then this air comes to the top. That means now this is containing air. That means here pressure is not zero. Okay, then see what we are doing here. When air is present, so when air is present, right, it is now mercury up to here. So now in this pressure is not zero. Take it as pressure of air, P suffix A. Now what I am saying is, if you are taking, if you are taking a point just inside mercury, pressure must be equal to that of atmosphere. I am taking now one more point at same level inside the cup, sorry, inside the tube. At this point also, pressure must be equal to that of atmosphere. That is P naught. Okay. Then see what I can write here. P naught must be equal to P naught must be equal to pressure of air, pressure of air plus H rho G. I hope you are getting this one. P naught is equal to pressure of air plus pressure because of the weight of mercury column. Okay, I am repeating. At this point, pressure must be equal to pressure because of the air plus pressure because of the weight of the mercury column. So it is now Pa plus H rho G. Okay. Now in this, there is no change, which is equal to 76 into rho of mercury into G. This is now pressure of air, which is non-zero, plus H rho G. Okay. Now from this we can say H value will be less than 76, right? Because this is non-zero. Okay. So length of the mercury column will be less than 76. Okay. So whenever we are taking pressure of air here, if air is present, then length of mercury column will be less than 76. Right? So answer is now, it is option D. Okay. Height of mercury column in that tube over the surface in the cup will be less than 76. Right? Let us take next one. A U tube of base length L is filled with liquid. If tube is having acceleration A horizontally, find the difference in the liquid levels. Let us see how to get it. Difference in liquid levels. It is given a U tube, a U-shaped tube. So given that acceleration is horizontal, acceleration horizontal. See, when there is no acceleration, the liquid levels will be same in both columns. Suppose it is somewhere here. Before having acceleration, same levels. But when there is acceleration, levels cannot be same. Now that is what we have to decide. Okay. Given that this base length is equal to L. Now see how to start. Suppose in this column, present length equal to or height equal to h1, present height. Initially h and h equal heights. Now if it is raised, this will come down. Okay. Suppose now this is equal to h2. Okay. In left column it is raised. In right column it is coming down. Okay. Means if you are not knowing in which column it will be raised, just assume randomly. So I'm assuming that in left column it is raised, right column decreased. Okay. So when we are getting answer, then we can conclude in which column liquid is raised. Okay. Now focus horizontal part of the tube. I am drawing separately. We are focusing the liquid column in the horizontal part. When we see from ground frame, this horizontal part of liquid column is having acceleration, that is a right side. I am focusing the liquid column in the horizontal part that is having acceleration. It is having acceleration means on this liquid column, net force must be right side. Okay. Now I am focusing left side force. It is equal to pressure P1. If this area is now A, P1 into A, that is now force by this part of the liquid column on this liquid column. I am repeating, this is a force by this liquid column on this liquid column at this phase. In the same way, because of this liquid column, force acting on this phase, that will be P2 into A. And as per the diagram, acceleration is now right side. Therefore, net force on this liquid column must be right side. That means this force must be greater than this force. This force is greater than this force means this height must be greater than this value. That means definitely h1 must be greater than h2. That means we can conclude that when it starts moving with acceleration, liquid column in left one must rise. If it is raised in right part, it has to come down. Okay. So I can write here P1 minus P2. P1 H1 rho g, P2 H2 rho g. So P1 minus P2. Let us take it as this is H rho g. This is a P1 minus P2 into A. This is now net force. Net force equal to mass into acceleration. Mass of this liquid column. Mass equal to length is L into area, that gives volume, into density, that gives mass. Net force equal to mass into acceleration. So I hope you are getting it. Now focus calculation part. In this, A cancels, rho cancels. What else left here? H equal to AL by G. Okay, that is the answer. So difference of liquid levels. When acceleration is right side, in the left column, liquid is raised. So H1 is greater than H2. And that difference, H is nothing but H1 minus H2. Okay. Let us see the next problem. A U tube of base length L is filled with a liquid. If the tube is rotating about one of its arms with a constant angular velocity omega, then Find the difference in the liquid levels. Almost same kind of question. Let us see. In the previous question, we have taken translation. It is now rotation. So again, making the diagram. So it is a U2, base length is almost same question. Right. It is now rotating about one of its arms. Let us say rotation about left arm. Okay. So axis is vertical. This is now axis of rotation. Okay. Initially means before having rotation, levels were same in left column and right column. So now what happens is in left column, it will come down. In right column, liquid is now going up. Okay. So now we have to calculate difference of liquid levels. That is H. Okay. That is what we have to calculate. Let us see how to start. So here it is now rotating. Again, focus the liquid column in the horizontal part. I am drawing here. This is the liquid column in the horizontal part. Now this part is rotating about its one end. It is now rotating about its one end. It is just like a rod rotating about one of its axes like this. Okay. Now we have to focus center of this liquid column is following now circular motion. See carefully. Center of this liquid column follows now circular path of radius L by 2. Okay. Now we have to provide who is providing centripetal force. Okay. You can see this is a following circular path and this will be center of that circle, right? Just focus a free body diagram for that. This is now center of the circle. By this part of the liquid force acting on this path, that will be like this. Okay. Suppose a height equal to this total height is now take it as h2 and this height is now h1. This is now p1 into a and this is p2 into a. Since center of this liquid column follows circular path, there must be centripetal force. That means net force must be towards the center. That means P2A must be greater than P1A. That means H2 must be greater than H1. So in this H means it is H2 minus H1. Okay. Now see calculation. P2 minus P1 that is H rho G. This is P2 minus P1 into A. This is now centripetal force which is equal to mass into centripetal acceleration and mass equal to area into length that is volume into density that is mass into centripetal acceleration is r omega square. Okay. Now see calculation part. Rho cancelled, a cancelled, h equal to l and l square. It is l square omega square. Here g is left by here 2 is left. L square omega square by 2g. This is now difference of the liquid levels. Okay. So just focus the center of mass of the horizontal part of the liquid, right?